These are our partners prototyping. And we went to get some feedback from the physicians who were testing this. And one of the guys who's using it said, I have all this feedback for you. I use it all the time. When I'm driving into work, I just dial a system because it's accessible via phone number. And I say, who's my first patient? And then I have a conversation. And we looked at the logs and he talks for 45 minutes. He talks to this thing. It's a medical colleague for him. And one of the things that kind of light bulb moment for me was, in a lot of contexts, you just want to have a conversation. And if you do something that you love, if we can make voice-driven, very natural interfaces that do all that stuff, it not only gives you back a couple hours of the day, but it actually gives you this whole new way of interacting with this field that you got into because you love it.
So hello, AI Tinkerers, and welcome to One Shot. This is our global stage where we invite true innovators to come and let us peek under the hood and ultimately try to get to, hey, how can you take my innovation and use it in your projects? And so today I'm here with Kwindla, or Quinn, as most people call you, I think, CEO, founder of Daily. And you have a long career, I would say, in real-time interaction systems, broadly speaking. So from MIT Media Lab and work you did there to Oblong Industries, which is a little bit I found as the claim to fame was the gesture interfaces in the movie Minority Report, which is the only thing you can remember from that movie. So great job. And then now Daily, which is really on the bleeding edge of live and real time voice applications with AI, generative AI and avatars and everything else. And it's just wonderful to have you on the show.
Thank you for having me. I'm a huge fan of the AI Tinkers community and events, and you helped us out with a hackathon yesterday, judging and coming by and talking to participants. Thank you so much for that. If the camera catches me yawning, it's only because we had 500 people participating in a hackathon over the weekend.
It was an amazing event, and so great to see so many people tinkering with your stack and your technology. And so why don't we jump in to some of that? It was so exciting. You've also done a bunch of stuff at Tinker, so thank you. In San Francisco, I saw you present back in August, and people loved your presentation. Tell me, I guess, give me a 10,000-foot view, first of all, with everything that's happening at Daily, because there's a lot going on.
We started Daily in 2016 with the goal of building the world's best infrastructure and developer tools for real-time audio and video. I love large-scale networking, ultra-low-latency networking, audio-video stuff. I have since I was a baby programmer. And I've done that kind of thing over the years in different contexts and different eras of the internet, which has been fun. There's more and more you can do with real-time audio and video every few years. And in 2016, there was a standard called WebRTC that was starting to get some traction. And I really felt like that was going to democratize and open up the possibilities for people having real-time audio and video in any application, in any web browser page, in any native app. We wanted to build great developer tools on top of WebRTC. And we grew little by little, and then during COVID, we grew a lot, and there was a roller coaster as a startup trying to meet all these new use cases that were coming online all
and that was driven by just everyone needed to be virtual and needed video infrastructure, and lots of businesses out there have different needs. It's not just a Zoom call for everybody.
Yeah, and applications range from things like telehealth, which grew an enormous amount during COVID, and now I think has become a standard part of medical care almost everywhere in the world, which is great, right? Online education, I'm super excited about making education available across distance, across time, and now with AI, we could talk endlessly about the possibilities of LLMs to transform education in really human-centric positive ways. Workplace collaboration, obviously the Zoom style interactions, customer support, live streaming, games that have live.
My perception was when I found Daily, actually before we ever met, before I saw you present, actually, I was looking to tinker with video. Found you guys. And I think my perception was the basis of stuff you started back then until now, or until recently, has been if you wanted to create it's a platform to help create these custom video applications. So if you wanted to create a software stack to go sell into medical, or you were one of the big medical providers already and you internally develop a custom that's locked down and audited, has the right user experience, integrates in with your office, you would use Daily to do something like that. And then more recently, you've gotten into generative AI and these real-time APIs and things.
That's exactly right. So our historical customer base is people building human-to-human communication. And you need two components of that. You need global infrastructure that moves audio and video packets around at super low latency, scale, reliability, compliance, security, all that stuff. And then you need SDKs that you can embed into the applications or the web pages that give developers APIs to access that infrastructure. The human-to-human communication stuff has turned out to be a great building block for human to LLM communication. And when GPT-4 came out, it like everybody, I think it blew our minds that this new technology was capable of these real conversational interactions, but it was text conversation. And so we started figuring out how to put the pieces together in our world to take that text and add a voice.
I can imagine. How early were you tinkering on that stuff?
Basically when GPT-4 was launched, we started. And I think it's just that I missed it. Like I was aware of 3 and 3.5 and I thought, oh, that's really cool. And that's like an incremental advance. But I've been doing this a long time and I've seen a lot of incremental advances in AI. And I was slow to see the sort of GPT-3 moment as more than an incremental advance, as the beginning of a series of step functions. In retrospect, I think it clearly was, but GPT-4 hit me upside the head like a 2x4. I was like, oh, there's a true change in the capability.
And I can't remember exactly when they released some of their voice stuff very, very recently.
May of this year. Right?
Okay, so back when GPT-4 came out, it was still, you'd have to be looking on Hugging Face and Replicate and trying to find open source voice things, or just the providers that came from the old school. And there was 11 labs emerging. Did you look at any of that stuff around that time?
So that's what we started doing, was taking transcription or speech to text models, and then GPT-4, and then text to speech models, and putting them together into the lowest latency processing pipeline we could design, and building a voice-to-voice interface with a 3-model sequence.
But you had to have been doing some of the voice-to-text stuff just for your core software.
We were. So we were aware of sort of the players in the space and what you could wrap around GPT-4. But the fact that you could build this full loop with an LLM in the middle just totally transformed what we could do. One thing story I tell about this is that since we were founded, our customers would often ask, hey, I want to transcribe every video call, every audio call. And we would say, great, here's how you do this. Transcription software is pretty good. It costs this much. We have APIs for it. It's easy. And then 1% of our customers would transcribe 10% of their calls. And it was just because even though the transcription was pretty good, it was like, what do you do with that data? It's unstructured human output data. And you just don't have that much you can do to get value out of it. But as soon as you can feed that unstructured data into an LLM in real time or not in real time, you have this amazing set of capabilities. And now a huge percentage of our customers transcribe a huge percentage of their sessions.
Sure. The next wave of even doing stuff with that data is not even coming yet, really. It's just
we have only scratched the surface of what you can do. And that was the first thing that really jumped out at me in the sort of GPT-4 moment was, oh, now you can do incredible things with unstructured data. And so I think for the first year of GPT-4, that's what a lot of us experimenting with GPT-4 talked about. Oh, this unlocks unstructured data. It's almost like we've now baked that into our assumptions about these models, and we're trying to figure out the agentic workflows and the function calling. But I still think that's a foundation that's worth coming back to, that we've just started to scratch the surface of.
Let's veer over to the car and let's rev the engine a little bit. Before we get into, you've got Daily Bots API, RTVI, Pipecat, which basically at least 60% of the teams used Pipecat, if not more. It was almost a given at the hackathon. So there's clearly something interesting. Maybe we'll start with Pipecat. And then there's these two worlds of what you said was layering all this with the LM in the middle and turns and voice to voice, but either with translating to text in the middle and back and forth or natively. What is Pipecat? It's an orchestration. And then you've got those two modes that are emerging in the world of like practical implementations. Lay the land and then maybe show something that working with it.
Sure. So Pipecat is an orchestration layer for these real-time AI applications. And the biggest source of traction there is voice-to-voice voice agents for things like customer support and appointment scheduling. But then there's this whole penumbra of use cases that we're starting to see around things like appointment scheduling and virtual characters. Real-time video generation is part of this. So Pipecat is a set of tools that we built internally at Daily for our customers to build voice agents. And we started to see everybody trying to build these things, reinventing the hard parts over and over. Phrase endpointing, turn detection, interruption handling, context management.
No matter what you're building, you're going to provide the ease of use for some of that stuff everyone was having to do, but you're not opinionated on what the application's necessarily going to be.
Yeah, so we open sourced all the stuff we'd built internally, and it turned out to be super useful, and now there are thousands of people using
When
Pipecat.
was it open sourced?
That's a great question. Sometime earlier this year, I think March or April this year, we pushed all of it out as open source. And we're really committed to Pipecat being that neutral layer. It started life inside Daily, but now there are lots of contributors outside Daily and teams at Apple and NVIDIA and Meta and Salesforce using Pipecat. And it is that orchestration piece that tries to give you building blocks that make it a 15-minute project if you're a hacker or a tinkerer.
What is Daily Bots API?
Daily Bots is our hosted Pipecat. So it's a wrapper around Pipecat that lets our customers host Pipecat stuff on our infrastructure. Since we've got infrastructure in like 75 data centers all over the world, we try to make it useful for new use cases. I love this stuff, so I'm excited about Daily Bots, but I'm even more excited about the open source stuff. I just think if you can make an ecosystem cohere in an interesting way, that's as an engineer, as a startup founder, like that's what you want to do.
Yeah, and I see you use I don't know if it's required or recommended Dockerized containers for things. It's all spelled out in the docs, but you could in theory take it all, and you don't have to use your hosted thing. You're good. But you're making it easy. It's the common playbook right now.
I think the majority of Pipecat users are not actually using Daily, just because there's so many use cases that are telephony dependent. And we do a bunch of telephony at Daily, but that's like a global market. And Twilio has amazing programmable voice telephony stuff. So you can use Pipecat and you can use Twilio. And I never even know you're using Pipecat, right? Because it's an open source project. Except you come to the Discord and you're like, hey, how do I do this? And I'm like, oh, which pieces are you using? Oh, great. Awesome. I'll show you not quite the simplest thing because I was hacking on something last week that I think is fun to show. And if we look at the source code, here's a Pipecat pipeline. And it's a fairly simple pipeline, but I'm going to show you it doing something cool. The idea is you are passing the data from a user somewhere out in the world. Maybe they're on a web browser, maybe they're on an iOS device, maybe they're on a telephone. You're sending that audio from that user to the cloud. And in the cloud, the Pipecat orchestration thing is running a little voice agent bot. And so we've just...
The thing that may be hard to get your head around, if you come from like the web socket, like I scrape a website, I have an HTTP request, it goes, does its thing, comes back. If I want to do anything, maybe I parallelize separate synchronous processes, but this is different, this whole RTC world. Can you explain a little the difference for someone who's maybe not experienced that?
It is a little bit of a different world. If you build websites, web apps, native mobile apps, you're used to like running a bunch of stuff on the local device and then making a bunch of API calls, which is a great pattern. But as soon as you have to do stuff at very low latency and you have to make stuff happen that is data processing, you usually need to run that stuff somewhere in the cloud. So Pipecat lets you super easily run these voice-to-voice loops of logic somewhere in the cloud. And you move the audio data from the user device to the cloud, the Pipecat bot runs, and then you move the audio data back from the cloud to the user. And we're very influenced by our many years of building like real-time video processing pipelines and low latency audio pipelines. So Pipecat is a set of sequences of filters or processor nodes that you pass the data through.
And the new version of getting annoyed with telephone answering systems of pressing the keys and listening to all the menus, the new version of that annoyance is latency.
Yeah. So the driving down latency is like number one.
You had a great stat about what is the human, like from a human interaction tolerance point of view, what's the limit? The slowest you could be and still be natural. It was 900 milliseconds.
We
800?
Typically target 800 milliseconds. If you took the waveforms of this call and you like visualize them in an audio editor, you and I are probably responding in about 300 milliseconds to each other. We're predicting what each other are going to say and we're leaning into the conversation. We're responding. We're also giving each other nonverbal and verbal feedback. Like, yep, that's pretty good. Yep. Okay, cool. I got it. So the idea is to try to get as close to that experience as possible with an LLM. And if you can be down below a second, if you can be at like 800 milliseconds, it feels natural.
It's not going to feel unnatural and annoying and uncanny valley and stuff above that. Okay.
That, once you get 1200, 1500 milliseconds, you start to get into that uncanny valley phase. And then you need to build UI elements that are like a ding sound so that you know the LLM heard you, or you have to temporize with
And at a
some
low level,
pre-recorded
for
audio.
just doing the most basic, I want to say something, have the LLM turn around a response in audio to the most simple question. What are all the things that have to happen that stack up, the things that have to happen sequentially?
You got to get the audio from the user's device, process it, encode it, send it over the network. Then you have to do all the AI stuff, including any content moderation, function calling, out to backend systems. And then you've got to re-encode the audio and send it back over the network to the user's device. So usually the network transport is 150 milliseconds or so, all in, including all the encoding and everything. And that leaves you 500, 600 milliseconds for the AI
That
stuff.
encoding happens even if you're using voice-to-voice models, because you're talking about the low-level encoding. And if you're using text-to-speech to text, it's going to add latency, right?
It is, although you can push the latency around in various ways, right? Like the speech-to-speech models that are coming out of the open source labs generally aren't faster than putting three models together. OpenAI, yet they will be. OpenAI has done a ton of amazing work on GPT-4o, and the latency there is 500 to 700 milliseconds, which is exactly what you're aiming for. I still am recommending that people deploying these things in production, which a lot of our customers are doing, use the three models, the speech, LLM, speech generation. We are definitely moving to a world where all of the big state-of-the-art LLMs are going to be natively multimodal, natively audio to audio, which is super exciting. There's still lots of interesting stuff around using multiple models and fine-tuned, cheaper, smaller models at scale for voice use cases as well. I think we're going to live in a multi-model world.
I can see that now, especially if latency really matters and all you're doing is some kind of retrieval thing. You don't need advanced reasoning for that, but you do value latency. You value speed.
You really do, especially if you've got a function call in the loop, which has its own latency. Like you may call out to a backend system, and that may take 100 milliseconds to do that database query.
On a GPU that's local, right? To save their network time. Is that a thing?
You really may. Yeah. So I like what Apple's doing with Apple Intelligence, although none of it's really fully shipped yet. I do think we're going to live in this hybrid world. Some stuff's going to run on your device. Some stuff's going to run in the cloud.
Right.
Some stuff's going to be a state-of-the-art big model that is running across a whole bunch of GPUs on a supercomputer. Some of it's going to be smaller models. Some of the smaller models will run in the cloud for a technical reason. Some of them will run on your device.
Yeah, makes sense.
I think the evolution of something like an open source framework like Pipecat is supporting all the things you want to do really well, making that happen at very low latency, making it easy to swap out the different pieces, and then supporting that hybrid world that is coming.
Yeah, cool. All right, let's see it.
Sure. So here's a pretty simple Pipecat pipeline. We've got the input from the user coming from the network. We've got a context aggregator that's keeping track of what we say in a multi-turn conversation, because all of the LLMs are stateless. As if you've been hacking on LLM stuff, one of the big kind of conceptual things to get over is you're sending something new to the LLM every time you run an inference call. So in a long-running voice conversation, you need to keep track of what the user said. You need to keep track of what the LLM said in response. And every time you talk to the LLM, you need to feed that back in. Here's the LLM element. Here's the voice generation or text-to-speech. Here's aggregating again into that context what the LLM said. And then here's sending back out to the user over the network. So these are the core
context
pieces.
Aggregator is a memory compression summarizer fill-in.
In this case, it's the simplest possible memory that it keeps a literal
record.
History. Yeah.
Oh, okay.
The only thing it's doing that's complicated in this voice context is it's trying to do a word accurate record of what the user heard. So if I interrupt, I don't want the LLM's output that came faster than speech happened to go into the context. I want the context to match exactly what the user heard. So that's a little tricky, but that's built into these core.
So you're setting up a pipeline, this array of things. These are steps that will run sequentially.
These are steps that will run sequentially, and they'll run every time there's input from the transport. So you can think of it as a loop. And this could be arbitrarily complicated. I can show you like pipelines that have 20 elements and that have parallel graph structures in them and condition. Yeah.
What's an example of why you would, the complicated thing is interesting?
You might want to switch between languages, and you might think one LLM is better at one language and one LLM is better at another language. So you have a branch and you switch languages dynamically. You might want to do content moderation, but you want to do the content moderation in parallel, not in sequence because of latency really mattering. You might have analytics, you might have usage metrics, charge. You might be calling out to a Stripe database. Every time the LLM comes back with something, you might want to stick a record in your Stripe database that you need to charge the user for that. So the idea is you could put anything you want in this pipeline. You can write your own little pipeline elements in a few lines of code, and it's totally extensible and flexible.
Okay, cool.
So we can run this pipeline. I'm going to run it talking to Anthropic Claude. So I have to join the call from my local device and join the call from the Pipecat side.
Understood. I'm ready to demonstrate my capabilities in a concise and creative manner, suitable for audio conversion of a web artist sitsu. I'll avoid special characters and respond helpfully to user input.
Very simple prompt.
I'll do my best to showcase my ability in engaging.
Can you tell me a joke? Why don't you tell me a joke? Tell me a joke, please. Try that one more time.
Understood. I'm ready to demonstrate my capabilities in a clear and engaging manner, suitable for audio conversion. I'll respond creatively and helpfully to your inputs without using special characters. Please go ahead and ask me anything or give me a task to showcase what I can do.
I would like you to tell me a joke.
I'd be happy to tell you a joke. Here's a light-hearted one here. Why do scientists trust atoms? Because they make up everything.
That's one of my favorites. Could you tell me another joke? Just one more, please.
Of course. I'm happy to oblige with another joke. Here's one more for you. Why did the Scarecrow win an award? Because he was outstanding in his field. I hope that gave you another chuckle. It was a great way to lighten the mood, and I enjoy sharing jokes.
This is one of my Insata favorites.
Can you save the conversation now?
I'd be happy to save our conversation. I'll use the save_conversation function to do that right away. Great. The conversation had been successful.
So I'll show you the function call in a second, but now I can load that same conversation, and this is all the LLM deciding what to do based on what I'm telling it I want it to do. So it's all LLM-driven function calling. I'm going to run that same pipeline, but I'm going to run it with GPT-4.
Okay. Where did you configure GPT-4 to switch? You got a different script ready.
I have a different script that has one tiny little element different, because these are actually examples that are in the Pipecat main repo.
Okay.
Hello. How can I assist you today?
Could you load the most recent conversation we had?
Okay, I've loaded that conversation.
I think you told me a couple jokes. What jokes did you tell me?
I just told you these two jokes. First, I asked, why don't scientists trust atoms? And the function was, because they make up everything. The second joke was about a scarecrow. Why did the scarecrow win an award?
So now that we've built these kind of core Pipecat abstractions, a lot of the work that's super fun is like gluing them together in these real world useful ways. Like you may want to use different LLMs, and how do you, they all have slightly different formats for the context, for the tool calls. They behave a little bit differently. How do we build the abstractions that make it really easy to build real world applications that glue these things together and are flexible?
One of the things I'm interested in is the saving and loading the conversation. So we all have apps built, and now we want to build voice interfaces on them, but we want them to do things like file a Zendesk ticket or look up something in a database or whatever it is that we already have built. Maybe we built a web interface for that, but hey, let's swap it over and just create a little agent that we can talk to, a little persona.
So here's the save conversation function. And again, we're tinkering here, right? This is the hackiest possible version of this, but hopefully you can see how you would extend this into an enterprise, like a real production quality use case. I'm saving it into a file in the temp directory. So if I reboot, I'm going to lose all my conversations. But I have pieces of this kind of stuff I run that I experiment with that don't save to the temp file, right?
Show me where this is called from in the Pipecat. Like where's the hook?
So there's two pieces here. There's three pieces. I define the save conversation call, and then I need to tell the LLM about it. So
it's a tool call.
It's a tool call, exactly. And then Pipecat has a mechanism for registering that function. so that in the pipeline, all of the different kinds of data frames that go through know that one of the kinds of data frames is a function call data frame, and all the elements that care about
This
it
is
will
cool.
get that
But
data frame.
okay, one of the coolest projects, I think you actually started it with someone who came to you, the open source. It was the Comfy UI for voice apps. That now it all makes sense because the coding that you're showing here is so simple. Like it's actually harder to understand the abstractions than it is to do the code. Yeah. Okay. And so what this guy built to the hackathon and is now open source, I think, is basically the drag and drop or low code version of stitching this together. That's interesting.
I'm really excited about that.
I can
They
see why.
called it Housecat
Oh yeah.
because Pipecat, Housecat, these are the PRs from there's no good graphic here. Maybe we can cut in his video from the hackathon, but there's now, as of this weekend, there's now a project to build Comfy UI for voice on top of Pipecat, and it's all graphical configuration of these pipelines. And I do think it makes the learning curve for this kind of thing so much better.
So as a developer who has existing apps, all you really need to do is have a first-class idea of what your functions are internally that you need to expose, and expose those as tool calls, do the prompt engineering, drag stuff together, and you in theory could have a working, and then layer on top of Avatar, which we also saw last at the hackathon.
Yeah, and hopefully you start with all of the great stuff that's just in Pipecat main, and then you have your own idea about, I can do this a little better, or I want to do this new thing. I want to integrate with this different system. And then you write a little bit of code and you make a PR and you submit it and it gets merged into main and gets released in the next release. And everybody who does a pip install Pipecat AI has access to that.
That's really cool. Let's talk more about use cases. So what are some of the craziest, amazing use cases you've seen in the few months since Pipecat?
I will tell you one that totally blew my mind. We were helping a customer of ours install a voice-driven medical scribe application in Georgia. And they had built this thing that let you summarize all the patient encounters. This is now a very, very fast adopting thing in healthcare. Takes a bunch of the workload of clinicians, like summarizing, writing notes after every encounter, because the LLM's actually very good at that. We had built on top of that some voice-driven interfaces that interacted with the appointment scheduling and the electronic health record system, mostly just to make the workflows a little easier. But they were very open-ended, and we hadn't locked anything down because these are our partners prototyping. And we went to get some feedback from the physicians who were testing this. And one of the guys who's using it said, and the other thing I do, like at the end, he was like, I have all this feedback for you. I use it all the time. I also, when I'm driving into work, I just dial the system because it's accessible via phone number. And I say, who's my first patient? And then I have a conversation, and we looked at the logs, and he talks for 45 minutes. He talks to this thing. It's like a medical colleague for him. And one of the things that kind of light bulb moment for me was, in a lot of contexts, you just want to have a conversation. And if you do something that you love, like all these people got into medicine because they love helping patients. And all of this other stuff gets put around a doctor's day-to-day life. And it's all conforming your work to what the computer makes you do. It's all it's all the menus and the buttons and the filling out the forms. And that ends up taking 2 or 3 hours of your day. If we can make voice-driven, very natural interfaces that do all that stuff, it not only gives you back a couple hours of the day, but it actually gives you this whole new way of interacting with this field that you got into because you love it and you love helping patients. I really was surprised that this guy has this new medical colleague that he talks to about patients on the way to work.
Yeah.
But it makes sense in retrospect.
It does. It's inverting the world. It's giving you more direct access to just the bag of tools and knowledge and not constraining you to this terrible medical web interfaces.
Yeah, which grew up for good reason, but they're very complicated and they're very constraining, and they force you to adapt to the computer rather than the whole computational stack adapting to you and your work.
Clearly, medical transcription is an area where there's been a lot of AI and there's been adoption, I think, there. But where in terms of voice interfaces, which is like the bleeding edge, like you're seeing, I think I saw you say somewhere there's like people are sleeping on how much demand there actually is for this stuff. Where are you seeing those early signs that makes you feel that conviction?
Call centers are a very large part of the economy, and the call center experience, both in terms of running it, if you're on the tech side in the whole call center customer support world, and in terms of if you call your electric company or you call a software vendor, It's going to totally change over the next 2 years. And that's going to happen almost as fast as the sort of medical transcribing use case, because both the economic ROI and the qualitative experience change is so large. So one small example of that is you should never have to be on hold ever again when you call a call center, because the LLM can at least start the call. And in 50, 60, 70, 80% of cases, the LLM can actually do everything you want to do on the call. And I'm not talking about just pressing the button and getting your account balance. I'm talking about fairly complicated things, because you were talking a little bit about RAG before we started recording. You've got 5 or 6 or 7 backend systems in all large companies that customer support agents are themselves navigating. You can pull all the data out of multiple systems. You can, in a smart way, turn it into context for an LLM. You can give it to the LLM, and you can get a huge amount of stuff done. And then
taking action on those, still
taking action on it, I think, is pretty much, I don't want to say it's a solved problem, but the building blocks are all there. So you can get a huge amount done just with today's LLMs, even if we don't have continuous improvements in what the LLMs can do and what the orchestration layers can do. And that's clearly happening too.
Is the pull for this, like people using your platform going to sell solutions? Is it consulting? Is it internal pulling it in to go build those systems?
All of those.
All of it.
It's the large companies that are trying to evolve their tech stacks that have big call centers as customers. It's companies that can disintermediate some of the call center stuff if this just happens in their cloud and their infrastructure. Tech forward fintech companies. And then it's individual startups building new stuff that transforms the tech landscape for people doing customer support. Yeah. It's layers as always. Like telephones aren't going to go away, but more of this stuff is going to happen with apps because there's more drivers for it. The old legacy systems aren't going to go away, but the LLMs are going to sit between the legacy systems and all of us and make everything feel just cleaner. And the LLM can always escalate to a person whenever that's needed.
What about wild and non-obvious use cases that you've seen?
I was just totally blown away by the voice-driven drone that the guy brought to the hackathon, and not just because it's really cool technology with a drone that flies around his neighborhood and tells him if Trader Joe's is busy and he should go now or not, but also because the way he's built it is such a nice example of these hybrid systems that are going to be the norm. He has complicated function calls that a state-of-the-art LLM kicks off, but then they use a whole bunch of open source models, some of them running on the NVIDIA Jetson on the drone, to do things like how busy is the parking lot, or make sure you're tracking appropriately to go where I want you to go.
That's a great example of using you use this YOLO on device, on the drone, because it's fast and real time, and latency otherwise would be too much to push it. He has to push some stuff to the cloud over wireless. In this case, he had to engineer the drone itself to be able to take on the payload of the NVIDIA device and the battery pack. Like, you couldn't just buy a drone and strap it on there. We had to engineer a new device. So that's a very committed tinkerer.
And he's just done such amazing stuff. And I think it architecturally shows where we're going. Also, popping up a level, my thesis is that we're all going to live in a context where we talk to LLMs all the time. And if you think about how verbal we are as humans and how much we get out of conversational interactions, and the bandwidth constraint on conversations today is you have to have another human who has time to have the conversation with you. LLMs are going to be part of our just sort of psychological landscape in ways that are just very hard for us to see around the corner and predict. But in 10 years, we're not going to think of a group chat as having just humans in it. We're not going to think of TikTok as mostly being human-generated content.
The hardest part, once the technology gets there, maybe just the habits of the people really to embrace that way. But like I used to say, if someone makes a book recommendation, why do you write it down and then go home just buy the book? If you're going to buy it anyways, just faster to just buy it than to write a note about buying the book. Yeah. And work itself becomes that way. Why, if you have an AI that has access to your context and some of your tools, then you could have a conversation at the end of it, get the work done. There's no other step.
No, that's right. And you can also have, we've talked a little bit about the value of long-running agents. And there have been some great presentations at AI Tinkers of people working on that. So you're going to have long-running agents, and then they're going to call you on an app or on the phone when they need your input. And you're going to do that synchronously if it's urgent. You're going to do it asynchronously if it's not urgent. So the getting the work done is partly a new kind of delegation. But the shopping thing is a good example. Like I lived through the very beginning of the internet mass market transition. And I can very clearly remember people saying, you're just not going to buy stuff online. Like, why would you buy stuff online? That's going to be a niche activity. You're not going to put your credit card into a website. It's too insecure to put your credit card into a website. And I just feel like some of those same patterns are it's useful to think about that experience and think about how much things are going to change when these conversational intelligences are just sort of part of our whole software and internet landscape.
Yeah, I think so. When people start to get used to it, the faster it gets and the better it gets, the more you'll do it. Even not just as a replacement for the old way, you'll actually do more of that behavior. And one thing that's taken over in terms of voice that surprised me is using a Whisper, a voice app on my Mac. One key and I type. So I use it for everything. Every form field, I use it basically for everything. And it just took over my keyboard usage because it's faster and it's accurate enough that it works.
And I think the next step there, and I've got some prototypes of stuff that I run locally that I need to clean up and demo, is the screen recognition stuff. LLMs are now very good at visual recognition. They're not good at certain kinds of geometry and bounding box stuff, but they're very good at telling you what's on screen. So you shouldn't even have to navigate between those form fields, right? The LLM should just be taking your screen.
It's brilliant context. I'm logged in as being my computer. That context is rich, and it's with me wherever I am if I'm at my screen. So have you done, just side note, and this is getting out of voice, but have you done any experiments with fine tuning? GPT-4 now has fine tuning available, and the open models. Have you done fine tuning on visual to do a better job of recognizing things on screen?
I've done a fair amount of fine tuning on text with Llama. I haven't done any visual fine tuning, but I would really like to because I think it's super interesting.
Yeah, I'm curious about if it can close which of those gaps it can close on the visual fine tuning.
There's so much good work going on in that area. I really love the stuff that Vic is doing with Moondream, and he's in Seattle with you. These small vision models have so much potential because they're so fast. But one of the big questions I think over the next couple of years in AI is a small vision model more useful for all the reasons that small models are useful, then the big models are getting better, faster too at vision. I tend to think there's room for both, and you're going to want systems that are smart enough to use both, but it's almost like a race between the very, very large models and the really specialized
for the
models.
case we're talking about, running on my M2 or M3 laptop and looking at my screen, it's got to be small and local and fast. And
so I tend to think the same way you do, but I will say that I always try to correct my own biases. Often I don't succeed, but like Mark Andreessen has this thing he said for years, which is that if you want to think about the future, imagine that bandwidth is free and the speed of light is not a constraint on like bit rate and latency. And I do think that's a useful corrective, because if you just had a big open pipe from your laptop to OpenAI's nearest supercomputer and it was free, would you actually run that model on your machine? I don't know. Like, I tend to think you would, because I like these hybrid low latency optimized at every end of every connection. But Mark's not wrong that you get a lot of mileage from imagining that bandwidth is not a constraint and cost is not a constraint.
Yeah. There's a world where the models themselves just slurp up a lot of what you have to build around to make a usable system, and when they get smarter too.
They do, and it's fun to be in an era where all of a sudden hardware matters again.
Yeah. What were you doing at a Media Lab, to jump way back?
So I backed my way into the Media Lab in a really lucky way, because I got interested in the internet when the internet was very new. And the Media Lab was one of those places you could go to do stuff with the internet. So I went right after undergrad, I went to the Media Lab and I worked with a wonderful professor named Mitchell Resnick on building educational computing systems. And the particular thing I was interested in was like little bits of hardware that talked to each other, and kids could learn to program by like using these almost programmable Lego bricks. In fact, I wrote the spec for the first Lego Mindstorms, like visual programming language, like product, which is super fun. And that I gradually got more and more interested in just the sort of networking and low level, like how do you build like big network systems that are super fast and that are programmable and flexible, and went in that direction. But it was amazing to be at the Media Lab in like the late 1990s, because I think it really was like every era has its own Xerox PARC. I think the Media Lab was the Xerox PARC for that moment. And there was like, money was not a constraint. Like people coming by who had things that you could beg, borrow, and steal to work on was not a constraint. The only constraint was hours in the day. And like we worked around the clock at the lab, and we had all this amazing stuff we all thought was blowing our own minds and would be applicable in the world over the long term. And I was just really lucky to be there. And then, of course, I didn't know how lucky I was, and I dropped out to do a startup, as you do. And that was its own fun transition and journey.
Yeah, I'm just turning to like scale now, deploying this stuff at scale. I think one of the things interesting about Daily is you're not coming to Gen AI as just a fresh startup. You've been doing through the pandemic, scaled video, live video conferencing stuff. So you're in a really good position to bring Gen AI into it. But what are some of those challenges at scale when you have a live stream with 100,000 participants, or if I want to create the phone scenario we talked about before and it's doing customer support for a big company? What are the problems that you're going to have? And how does Pipecat scale? Like, how does that work?
I think one of the advantages that we have was we've had a lot of climbing up the learning curve at running enterprise workloads at scale. And for the stuff we do, my co-founder Nina often says we were really dumb starting a startup where like you can never ever go down, like you can never have any downtime, because at any hour of the day, somewhere in the world is doing a video call on Daily. And if that video call doesn't start or if it dies in the middle, they are very unhappy. So we care a lot about uptime. It's interesting that we're shipping, not we, I hope, but the generative AI world is shipping stuff so fast that uptime and latency guarantees and rate limits and reliability are not the focus for most companies. And I understand why, because we're inventing this stuff from scratch, or the people who are doing the inventing of that stuff are inventing it from scratch. And it's so cool. But we have now a whole new layer of service outages to contend with some of our new partners in the generative AI world, because the rate limits and the latency guarantees and the kind of uptime are just not there yet across the whole board in generative AI. So one thing that our enterprise customers are often asking us about is how do you build like failover between providers? And I actually hope that goes away pretty soon, because I do think that is one of the things that's holding back enterprise use cases. But part of it is just NVIDIA has to ship more GPUs. We're all trying to do this stuff and there aren't enough
You
GPUs.
think a lot of the failover is just that. Is that where the root cause of some of the fails are?
It is. People just don't have enough capacity.
Yeah, interesting.
And it's funny. So we're used to thinking of several 100,000 simultaneous video calls as not a big deal. But I will often go to a new provider who's like a new model provider that we want to integrate into some enterprise stack. And they're like, oh, we could do 100 concurrent users for you. No. 100 concurrent users, we could do demos. But 100 concurrent users is not a production system. And they're like, oh, nobody's needed more than 100 concurrent users. It's really bad. It's probably more like 200. I'm like, no, we need a different kind of like rate limit guarantee from you.
Yeah, interesting. Talk about, okay, so I noticed your background, you've got some work on political campaigns and open source advocation, public sector stuff. Obviously, like, we're geeking out about tech. That's all we want to really talk about. But I have to ask, one of the most fascinating things is, and dangerous, scary things, is voice cloning, how good that is. I remember at some point a year ago when I've turned Tortoise was the first one for me. It was like, wow, this is scary good. I trained a voice model on my own voice that could fool my mom. And I sent it to my CFO at the time. And I said, because we were getting phishing just on email with, this is from Joe, please transfer money, whatever. So I sent him a voicemail that was me saying, I typed it in though, but it was my voice saying, hey, I don't have time to explain, but you need to I'm stepping on an airplane. I can't explain right now, but I'm about to send you a bank transfer request. You need to approve it. When I land, I'll call you and explain, but if we don't make this transfer, it's going to be bad. I said something like that. It was very credible in my voice. And then I said, this is the example of what's possible for free. And that was a year and a half ago. Now it's just like drag and drop easy. And then you can use Pipecat and orchestrate a gajillion of them. I crawl LinkedIn and then I go find YouTube clips of the person. I could create 10,000 phishing bots and I could go kidnap children and you won the lottery and your kid's in an accident, all at scale for very little money. What is your thoughts on it's out of the bag?
I do think the cat's out of the bag, and we need to do a really good job educating folks really quickly on how realistic voice cloning is. And it, again, is like the early days of the internet where email felt very credible to people, and you could get spoofed or scammed, and lots of people were, and sent money to people who had very credible stories, all via email. And I think we were too slow in educating people about that.
Yeah. And education helped a lot. And spam folder kind of protections and things.
There are some technology solutions. I'm a little bit skeptical about the technology layer solutions there because it's an arms race.
Yeah.
It helps, but I do think education is really important. And I also,
I saw a great post where someone put the Declaration of Independence into an AI detector, and it said, yeah, 96% chance this was AI generated.
I didn't see that. That's really funny. One of the huge cohorts that had very fast adoption of ChatGPT is like high school and college students for very obvious reasons. It's like super, super helpful when you're thinking through things and learning about things and when you're writing papers. And we're just going to have to come to terms with what that means for education.
Maybe ironically, it's all of this sort of like satirical, political deepfake stuff is actually serving a positive function in society of educating many people what's actually possible.
I think that's true. And I think it's also always worth stepping back and trying to separate into categories the things we're worried about. The scamming people is a very specific category and a very large and very worrisome one. The deepfakes for politics, I did work in politics for several years. I do worry about that, but that's not qualitatively new to me. In a world where Fox News has existed for 20 years, people believe a lot of stuff that's not true already. It's not clear to me that political deepfakes are going to qualitatively change the landscape there. I could be wrong. I have been wrong about things before, but I think that's a separate vector of stuff to worry about. I'm a little bit skeptical that we can figure out the right regulations to help with this stuff too. We already have laws against doing stuff that's illegal, and we should enforce those laws, but I really think it's very much about an educational component.
What's the simple two-factor auth analogous tech solution for protecting against deep fake influence?
It's a password. Yeah, like you need to have a password with your family that is non-public that somebody couldn't figure out.
And
from
communicate on secure channels where they can't intercept it.
Yeah.
People need 2FA for their relationships now. That's what that means.
It's right. It's true.
Very cool. What are some of your under the radar Gen AI startups and projects that you're seeing? You're here, people coming to you with Pipecat, they're going to the hackathons. What are the under the radar things that are emerging that you're excited about?
It's been really interesting to me to see how much of the YC startup class in each batch of the last few batches has been Gen AI, 80%. And I totally get it because it does feel like the early days of the internet, where if you're tinkering with this stuff, it's going to change everything about how software is built, how we use software, and how we distribute it and charge for it. So if you're not working on it, it feels like, unless you have a very strong passion in some other area, this is the thing that has the...
What are some of those things you've seen?
That's a really good question.
And you've heard about things that have more traction. There's Voca AI. You said Mercure. Is that one of your partners? Or
yeah, if it's okay to talk about daily customers.
Sure.
I really love this platform called Vappy that folks are using to build voice agents. A lot of people used
it last night.
I think half the people at the hackathon used it.
So how does it work?
It's a really nice dashboard and set of tools for building voice agents. So you can build a voice agent that does a huge variety of different things, and it's programmable, scriptable, and you can connect to those voice agents from the phone or from the web. And they just did a really nice job on the tooling. We have a customer.
There's tools and interfaces to go build essentially on top of Pipecat.
It's a Pipecat-like thing, but at a higher level.
Okay.
Yeah, exactly.
Does it do more than just that, like monitoring it?
Yeah, they have workflows, and they just have all the things you would need to deploy something to an enterprise. And they just batteries included.
And it sounds like great for just a weekend project too.
Yeah, I think they've hit this sweet spot where the learning curve is very gentle, but you can do a ton, which is hard to do.
Yeah. So if you wanted to just mess around and show your friends some voice app you built that maybe does one little integration with your thing, you would probably use that.
I think you would use Vappy. We have a partner, I really love what they're doing, called Mercor. They're doing virtual job interviews.
Oh, yeah.
But that very much undersells it because
a few of those I've seen.
There are a bunch of people who've seen that with generative AI, you can transform the hiring process or the job search process, depending on which angle you're coming from. So if you're a junior engineer who just graduated from college, and you may not be in the US, you may be outside the US in some other market where jobs are not as plentiful for software engineers. Can you practice so that you do a really good job in interviews? Can you be part of a network that can highlight you if you're particularly good fit for certain kinds of jobs? And then can the interview loop especially with big companies that have complicated hiring processes, just get simpler, more streamlined, less repetitive, more egalitarian? So Mercor's building this whole suite of things, but the core of it is I do some subset of the job interviews virtually with an LLM, and it works really well. And one thing I like about the team is they have a very big vision for how they can make life easier and more productive for a whole big part of the economy.
Yep.
But they're taking it kind of step by step, and they're building the generative AI-based tools one step at a time.
It's interesting to think about. There's been avatar things for years, for decades, going back pretty far. People have tried to experiment with this stuff. And so I think we all have this taste in our mouth that like, yeah, but it's cute. It's a nice party trick, but that'll never be used in like a real interview. Yeah, I get there's a startup. I get they got funded, but that'll never be used for real. And yet I would think that just over the last even 2 months, opinions are changing on that big time, to the point where it's real. It's happening now. It's further along than you think, and you better go check it out.
And good software always has a lot of elements. And I think we sometimes even as engineers, I think we sometimes undercount how good putting multiple important elements together just changes the user experience. The winner of the San Francisco track for the hackathon last night, I thought was a really good demo of that. It was a driving navigation companion cruisy.
So cool.
Ooh, that video is great. That combines a bunch of things. It was a VAPI voice interface. It had a avatar from Tavis, which is the generative AI. And even though it's a small video avatar, having that like face talking to you really changes the feeling of the experience.
People may not have experienced that, but it is a two-way conversation where you get pretty instant responses in a human-like way. It's not dominated by this uncanny valley feeling, and it feels live and responsive in real time. You get a personality, and then so you're driving. It's like a dashboard. You're driving, and it's like your friendly trip.
And then it has the map, like the Mapbox API. So it has all these things together.
Hey, my dog needs to go to the bathroom, and I'll go, oh, there's a dog park over here. Would you like to navigate there? And it's really good. They did a great job.
It was really good. And it was that thing where you're putting together a bunch of UI pieces that together are the whole is more than the sum of the parts. And they're all different APIs, but they fit together for this use case.
So this different user experiences that use voice and the computer. I'm talking in a conversation, but then things are coming in front of me is really compelling. And then going all the way back to Pipecat for a minute, you showed us that the sequences there. Like, just explain to a developer how you would do the simplest thing of detecting, I guess the tool call, right? It's detect that we're talking about mapping and call a tool call, and then that's just going to change something in my app. That's it.
Yeah, so the LLM makes the function call, but the LLM doesn't really know anything about what the function needs to do other than what you told it. And then the function call does something arbitrarily complicated and returns arbitrarily complicated data. So one of the things I'm excited about that I think we're just starting to see is the idea that all software is going to have these totally fluid, liquid user interfaces in the future. Yeah. Like the LLM is going to let your system know what's going on, and your application is actually going to completely change its UI out from underneath.
It's a lot more time will be spent just on business rules then, and constraints. And
I think we need a whole new layer of UI toolkits.
Is there anyone building that?
I've seen some great demos on Twitter. I haven't seen anything that feels like it's all the way there. I think we may end up in the sort of Winamp MySpace era of this stuff before we get all the way to where we want to be, where everything is overly complicated and then it gets simplified back down, and like great designers.
I think you have the benefit, like me, of having moved through the internet and mobile, where there are points in time where if you have been asked who are the top 5 and which is likely to succeed, everyone was wrong because none of the top 5 were.
No, and our ideas as we built
GeoCities,
towers of ideas,
Netscape, Nokia,
Friendster.
Yeah,
I remember when Steve Jobs was like hardcore that everything on an iPhone and a Mac screen needed to look like skeuomorphic, needed to look like a leather bound.
Yeah.
So we got to go through these like cycles of it.
The education of everyone about how to do it. Interesting, fun. Was there anything else you'd like to cover before we wrap it up? This is a great conversation. Thanks so much for coming on here and showing us under the hood a little bit. I hope to tinker with this myself very quickly and very soon here. So.